Well, there's ample evidence that the Earth is warming, the climate is changing, the glaciers are melting, the Arctic sea ice is melting, the amount of energy that's carried by hurricanes each year is increasing, which correlates with the increase in the temperature of the surface layers of the ocean. The intensity and the number of hurricanes is increasing on average. So we have abundant lines of evidence of climatic change that are all consistent with the additional energy trapped in the atmosphere from increasing levels of greenhouse gases. Here we see temperature anomalies. It's now going back 170 years, sea surface temperature, temperature over the ocean, sea level rise. So here we see that the sea level rise has gone up by about a foot, 30 or so centimeters. And as I said earlier, some of that rise in sea level is just due to the ocean being warmer, which causes it to expand. And the amount of summer sea ice in the Arctic is declining quite dramatically. So there's a lot of evidence, not just take the temperature. A lot of things are changing in the Earth system. So what I really want to highlight in this part is what's the real cause of it. We know that we are doing a perturbation to the system by putting a large amount of CO2 into the atmosphere. We know that the atmospheric CO2 is rising. What is the evidence that says that that's what's actually causing the change? There are several lines of evidence, actually, but here's one of the most compelling. The curves here show the effects, the outputs of computer simulations, sophisticated models of the climate, where you put in all the information that you have about what the sun is doing, what the various inputs are to the climate, and run and what the atmospheric abundances are of greenhouse gases and so on. And you calculate what would the temperature be. And the blue curves show what the temperature would be over the course of the 20th century, basically, without including human-introduced greenhouse gases. So the blue curves is only natural things, the sun, volcanic activity. The green curve includes anthropogenic forcings, which is primarily greenhouse gases, but also additional aerosols. This is suspended particles in the atmosphere, which can have a cooling effect as well. Ozone, so things that are coming from human activity burning fossil fuels. And then the red curve is what's the actual temperature. And lo and behold, the actual temperature can only be reproduced if we include the anthropogenic forcings of greenhouse gas emissions. And if you don't include that in the model, then the model doesn't agree with the temperatures anymore. So, and you notice again in the early part of the 20th century, all three curves are roughly consistent with each other. And of course, back then, the amount of greenhouse gas going into the atmosphere was much less and able to be buffered by the rest of that system in the carbon cycle that we have looked at. So the models of the climate can only reproduce the actual observed temperatures if we include everything that's going on, including anthropogenic greenhouse gas emissions. This curve just shows what the magnitude of those different forcing agents is, and the upper plot shows the actual temperature record together with a computer model of the temperature, and that computer model is fitting the actual temperature measurements quite well, but it only does that if we include those greenhouse gases. So that's really the bottom line. This cycle has been affected by increasing the amount of greenhouse gases in the atmosphere. You see that listed over here on the right, which increases the amount of energy absorbed by the atmosphere, and in turn increases the amount of energy of infrared radiation coming back down to the planet and absorbed by the surface.